Alrighty, so now we are on to section C.2, solving quadratic equations. So C1, we learned about linear equations. Sorry, gotta get comfortable. And power equations. Now we're expanding upon that, kind of combining the two, if you will, to solving quadratic equations. So if you're thinking, what's a quadratic equation? Good question, we're about to figure that out. So we define a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. That's really important. Equals 0. So basically a quadratic expression just set equal to 0. Where a, b, and c are all real numbers, and really specifically a can't equal 0, or else if it did, it would be a linear equation. Okay? So there are actually a few different ways solving quadratic equations, and we're going to talk about 3 of them today. So the first one is by factoring. We're really good at factoring now. By what's called completing the square. That's not how you spell that. There we go. Completing the square. Excuse me. And by use of what is called the quadratic formula, which will be your new best friend. Okay. So let's work on solving quadratic equations by factoring. It's pretty fun. So if the quadratic factors easily, that's when we're going to factor them, right? So we think we did a problem in B2 that was like 15x squared, something, and I was like, definitely had to use the AC method to factor it. But it's still factored easily. Sometimes it doesn't factor with whole numbers, and that's what I would consider it doesn't factor easily. So if the quadratic factors easily, we can utilize the following property. This is a really big property. This is called the zero product property. I'm gonna really highlight it. So if I have A times B equals 0, so something times something equals 0, that's only true if and only if A equals 0 or B equals 0. I'm assuming A and B are not equal, so only one of them can be 0 at a time. So if 2 things are multiplied together, or any number of things, 3 things are multiplied by each other, at least one of them has to be, the only way that is possible is if one of them is 0. If and only ifs they're like the green arrow. They're like the highest, most important priority. Like you are the only person that can, I don't know. It's like really big if something is an if and only if statement. Okay. So we can use this property, the zero product property, to solve quadratic equations that can be factored as follows. So first I'm going to set the quadratic equal to 0. So move everything onto one side so that the other side has nothing on it. So there's 0 on the other side. I'm going to set the quadratic equation equal to 0. So I'm not just going to all of a sudden just decide equal to 0 and it's somehow equal to like 4 on the other side. Got to move things over. Right? So this may require you to move all the variables and constants to one side of the equation. Then once I've done that, I'm going to factor the quadratic and set each factor equal to 0 and solve. So this method only works when the right-hand side is set equal to 0, right? So just really focusing on that. Okay, so, and then we're going to start over here. All right, so solve the following by factoring. So great, we've already, step 1, already done. X squared minus x minus 12 equal to 0. I already have it set equal to 0. Beautiful. Now, that's step 1. Okay, sorry, I was reading something else. Now, step 2 says to factor the quadratic. All right, so x squared minus x minus 12. This is going to factor to x minus, is it minus 4 plus 3? Negative 4 plus 3 is negative 1. Yes. Okay. Equal to 0. So now the zero product property says for x minus 4 times x plus 3 to equal 0, either x minus 4 equals 0 or x plus 3 equals 0. So that tells me that either, I'm going to move 4 over, that x equals 4. Oh my gosh, the FedEx guy is coming right now and he's playing his radio really loud. So if you can hear it, that's pretty funny. I really hope there's a knock at the door. Duke's gonna bark. Oh yeah, so we have one solution, x minus 4, and then I subtract 3 onto both sides, so x equals negative 3. And that's my other solution. And if we wanted to, we could go over and check. So 4 squared minus 4 minus 12, that's going to be 16 minus 4 minus 12, and that for sure equals 0. Negative 3 squared minus negative 3 minus 12. Oops. Really hope he's not playing anything inappropriate. 9 plus 3 minus 12, so 12 minus 12. And then again, also equals 0. Pretty cool. So why do we need this set equal to 0? Why? It's called a zero product property. So it's only when the product equals 0. So think about it. If it was equal to any other number, there could be an infinite amount of possibilities. So if this equaled, so if I had like a times b equaled 4, well, a could be 100,000. So b would equal 4 over 100,000. Or a could equal 1 and b could equal 4. And this can continue on forever. A could be any number and b would just be 4 divided by that number. But when it equals 0, one of them always comes out to be 0. At least one of them. Okay? So that's why it only works with 0. So we see here, this is equal to 8. Even though this is already nicely factored, it's equal to 8. So x plus 3 could be 100,000, and then x minus 4 could be 8 divided by 100,000. And I could do that with any way. It's not likely for us to have infinite amount of solutions, okay? I was about to eat an apple, and I thought that would be rude. So what I actually have to do in this case is multiply out my left-hand side, which is the side with x plus 3, x minus 4. I still am not very good at left and right, even though I wear contacts and I look at something that says L and R every morning. Left-hand side, okay. This is gonna be x squared minus x minus 12. It's just what we did above, but now it equals 8. So now I want it to be equal to 0. So I'm gonna subtract 8 from both sides. So now I get x squared minus x minus 20. Now I can factor. Great. So I've done step 1, getting everything onto one side so that the other side is 0. Now we're going to factor. So it's going to be x minus 5, x plus 4 equal to 0. So then that tells me in step 3 that x minus 5 equals 0 or x plus 4 equal to 0. So x equals 5 or x equals 4. All right. No, negative 4. There we go. And the reason I knew that I was double checking myself is when I plugged it back into here and I put 4, I would have gotten 0, not 8. That's why it's always good to check. Yee. All right, and then we can do something similar. remember, I think it was I just had to re-record the last half of B2, and that's when we talked about substitution. So let's call it y. Let's say y equals x squared. I think we had a really similar problem to this. And maybe it was like 16 or something. So let's call y x squared. So I have y squared minus y minus 12 equal to 0. This is just helping factoring. So step 2 would say that y minus 3, y plus 3, y minus 4. It's the factoring that we've been doing this whole time. So now you have two options. You can solve for y and then plug in for x, but I would really just suggest writing x squared plus 3 x squared minus 4 equal to 0, because now that we've done that, we can see that, oh, what's that? It's the difference of squares. And that'll really help out when we're factoring. And it really helps you because we just talked about power equations. If I take square root of something, I have that plus or minus. So if you were to go off and solve, you're like, oh, y equals -3, y equals 4. So then x squared equals -3. It gets a little bit confusing. So let's just keep factoring. So we get x squared plus 3, x minus 2, x plus 2 equal to 0. Oh my God. Flies in my house this past week. We have 5 of them in our neighborhood. Okay, cool. So we're still on step 3. So I'm going to set x squared plus 3 equal to 0. That's x squared equal to -3. Ooh, that's going to give me no real solution. Remember that. There is a solution, but it's just not real. Okay, my God, fly. It's all my peony. It's all my flowers. Okay. X minus 2 equals 0 and x plus 2 equals 0. So x equals 2 and x equals -2. So cool. So we have two solutions, 2 and -2. And I think we could go ahead and check that and plug in there and you'd be good. Okay. And then sometimes I've also seen people write like x equals 2 comma -2 in a separated list. That's also the same thing. So you like put those together. All right, cool. Let's do like a harder factoring one. Okay. So whoopsies. 6x squared plus 7x minus 5. So I can't pull out anything right there. So what's a is 6, b is 7, c is -5. So I want d plus e to equal 7 and d times e to be -30. Okay, 3 and 10? Yeah. So I think 10 and -3, right? Because 10 minus 3 is 7, but 10 times -3 is -30. Okay, so we have 6x squared. So this would be step 2 since step 1's already done. Make sure I'm recording. Plus 10x minus 3x minus 5 equals 0. So I'm going to keep factoring. So factor B grouping. And that would be the second one. So there's an x and I think 2. So I'm left with 3x plus 5 And then both of these guys have a negative, so it's probably going to help if I pull out one of those negatives, 3x plus 5. Okay, great. So 3x plus 5 and 2x minus 1. Don't forget, I'm basically, when I'm removing a 3x plus 5, I'm going to divide 3x plus 5 by each term. So this divided by 3x plus 5, I'm left with just 2x. 3x plus 5 divided by 3x plus 5 is 1. And that's where there's a 1 right there. All right, cool. So step 3 says 3x plus 5 equals 0, or 2x minus 1 equals 0. So 3x equals negative 5. X would equal negative 5/3. And 2x would equal 1. And x would equal 1/2. And I'm, again, if I'm going through this really fast, I'm sorry. I'm under the assumption that you guys can like kind of pause if you're like, whoa, we're writing way too fast. Or even if you're watching this on YouTube, which I think I recommend because it has closed captions. I love closed captions. You can even slow me down a little bit. I think you can put me out like 0.85 or speed me up to 1.15. All right. But always feel free to email me and I'm going to update my office hours soon. Okay. They should be updated already if you're watching this on Thursday. Okie dokie. So those are our answers. And like always, we can always double check by plugging them in. Okay, so that's factoring. I think we're pretty good on that. We've been factoring for a few sections now. We're just adding in that I need to set each factor equal to 0. And we're kind of giving even more practice in factoring, which is great. So solving quadratic equations by completing the square. So this method, the first time I taught it, I think I confused some of my students because I think I explained it in so many different ways that it was a little confusing. So I'm gonna try my best, but this is kind of one of the sections that if the way that I present it is confusing, I will not be offended if you supplement after watching my video, going and like watching a Khan Academy video on this. Completing the square, it's straightforward as in you do this, then this, then this, then this, which you can follow the steps, but if you don't know why, that why part isn't as straightforward, if that makes sense. Okay, let me move my little head up. I want to make sure I'm not in the middle of the screen. Okay. So sometimes we aren't able to factor an equation, right? So when that happens, we can then try to complete the square. All right, so remember a quadratic equation looks like ax squared plus bx plus c equals 0. Okay, and we're gonna be talking about a, b, and c in such a way. So I want to divide the polynomial by the leading coefficient and put the constant unknown on one side. So what that means is this would look like, it's just because completing a square is a lot easier when the leading coefficient is 1. That leading coefficient is a. So we would look like x squared plus b divided by a x equal to negative c over a. But that looks really confusing. So we're just going to say that it looks like x squared plus bx equal to negative c. Okay. Just to kind of that dividing by a, I don't want that to get too confusing. So basically, I just want to make sure that my equation kind of looks like this. My leading coefficient is 1. It's fine if something is in front of x, and it's fine if something is the constant, but I just need all the constant to be on its own side. Okay. Oh, and so our polynomial will look like x squared plus bx plus or equal to c. Actually, we're gonna keep, I was gonna change the letters. So I know this is kind of confusing because I've changed what B and C are from what the original is, but I'm kind of just using them as C is the constant involved. B is the number that's in front of X, not specifically the number we started with, but just whatever is in front of X. It's a placeholder right now, right? So I'm going to add B divided by 2 squared to both sides of the equation. So now it'll look like X squared plus BX plus B over 2 squared equal to, and what we do to one side, we have to do the other, B over 2 squared. So the reason that we do this is because given that A is the coefficient of X squared is 1 and the coefficient in front of X is just B, I can choose this constant. This fly is following me. I can choose this constant such that I pick what it's going to factor to. That constant changes how, like, the outcome of my factoring. And we saw that on the second problem. If I scroll up here really quickly, x squared minus x minus 12, well, that factors to this. X squared minus x minus 20 factors to this. So just by changing that constant a few numbers changes the factoring completely. And that's the point of adding b divided by 2 squared. Oh my God, where did it go? There we go. So, but why did we choose b divided by 2 squared? It comes back to one of our formulas that we learned in B.2. Wow, I'm really glad I re-recorded this right now because I'm learning. It's all fresh in my brain. So remember that x plus y squared equals x squared plus 2yx plus y squared. Do you remember that formula we learned? Well, if I look at x squared plus bx plus b divided by 2x, what we have up here, that would say that 2y equals b, and y squared would be b divided by 2, that quantity squared. And you can see that because y equals b over 2. And so y squared would just be that. Okay, that arrow isn't going anywhere. Flying one in my ear. So from that, x squared plus bx plus b divided by 2, that quantity squared would factor into x, this is a plus, so plus, there we go, b divided by 2 squared. So you're like, okay, cool, it factors, that's great. This factoring is always guaranteed. I divide my coefficient, and as long as the thing in front of x squared is 1, then the coefficient in front of x, I divide it by 2, and then I square it, and that's what I add on to both sides. The reason I move c over to the other side is just to help with the factoring, okay? And then the reason that I chose b divided by 2 squared so that it would factor into this is because, great, now this thing, remember we have this on the other side. This is just a number, whatever c and b are. I'm going to take the square root on each side and solve. I can take, the factoring's already given to me. I don't have to think about what this thing is going to factor to. And I solve it like a power equation. I take the square root of both sides, plus or minus, don't forget that, and then subtract b2 and move it to the other side. All right, so let's watch that in action. So right, you would have like x plus b over 2 equals plus or minus the square root of minus c plus b over 2 squared. And you would solve from there, right? So I have x squared plus 6x plus 7. So my leading coefficient is 1. Beautiful. I need to boot 7 over. So step 1, x squared plus 6x equals negative 7. Great. Oh, negative. That's fine. Don't worry. So then over to the side, I would be like, ooh, b is 6. Okay, cool. B over 2 is 3. B over 2 squared is 9. That's literally, I write all 3 of them because I need all 3 of them. Well, not really B, but it's useful. So then I'm going to have, so step 2 says add 9 to both sides. So x squared plus 6x plus 9 equals negative 7 plus 9. Great. I'm not even going to think about what it's going to factor to because I know it's going to factor to x plus what's b over 2? It's 3. That quantity squared. And then this is going to be 2. So I don't even have to think about, oh God, AC method, like what does this factor to? No, I chose 9 so that it would factor this to this specifically. And we saw in those first 2 problems, if I change the constant, it changes what's factoring it to it. Additionally, the factoring is unique. I cannot factor x squared plus 6x plus 9 any other way. It can only be this way. So I choose the one constant such that it can factor into something squared. And the reason I want that something squared is because of how we talked about the zero product method. I'm not doing that. I can't set each one of these equal to 2, but what I can do is take the square root. So when we're saying completing the square, I'm completing the square by adding the 9 to complete that I can factor this into something squared, and it's unique. So the only way to get x plus something squared from x squared plus 6x is to add 9. And that's from the derivation up here. Okay, so great. I'm now going to take the square root so that I have x plus 3 equals plus or minus the square root of 2, which then tells me that x equals negative 3 plus or minus the square root of 2. We wouldn't have been able to figure that out any other way. I wouldn't be able to factor and know, oh yeah, one of the factors is going to be, no. So that's why the cleaning the square is useful. Okay. And with practice, it's going to be really quick. Okay, cool. So let's do another one. So this one's 2x squared minus 3x plus 4. So I don't have, whatchamacallit? My leading coefficient isn't 1. Your leading coefficient is the coefficient of the variable of the highest power. So x squared, 2 is bigger than 1. So 2 would be our leading coefficient. So I want x squared minus 3 over 2 minus, well, 4 divided by 2 is just 2. 2x, right? Equals 0. So I divide my Elliott coefficient. And I need to kick that 2 over to the other side, equal to 2. Okay, so now I can, step 2 says that I need to add, what's my b in this case? My b is negative 3 divided by 2. I have messed this problem messed up a lot, so I need to be careful. So b is negative 3 over 2. So b divided by 2 is negative 3/4. Yes. And then b divided by 2 squared would be 9/16. Okay, cool. So x squared minus 3/2 x plus 19/16 equal to 2 plus 9/16. I think I might have said 19 earlier, but I meant 9. Okay, great. Ugh, that looks really hard to factor. I don't care. I already know what it's going to factor to because I chose 9 divided by 16 so that it would factor into x plus something squared. And that factoring, so x plus, it's going to be b over 2. So b over 2 is negative 3/4. So x minus 3/4 squared. And let's see, 2 plus 9/16 is going to be 32, 16, which equals 41. Yes, 41/16. All right. So again, I chose this factoring because I'm just going to take the square root. So x minus 3 divided by 4 equals, don't forget your plus or minus because we're always taking the square root, 41/16. And I can actually simplify this to be, remember, radicals are just rational exponents. So this would be like the same as saying the square root of 41 divided by the square root of 16, which is just 4. So that's why it's really important to make sure that you're clearly writing that the whole entire fraction is in the radical right there versus this right here. Okay? So we're going to continue on right here. So that x would equal 3 divided by 4 plus or minus the square root of 41/4. And if you wanted to, you can combine those fractions, 3 plus or minus root 41/4. Ooh, I get to sing this lecture. So that's the same answer. Written differently. I don't want you guys to think that it's the two different answers. They're the same answers, just written differently. Okay, cool. So I think we have one more problem. Yeah, cool. So again, just practicing completing the square. So if you want to, I've done 2 problems already. This is usually what I would say. All right, you try it. Okay. So pause, work it out on your paper, unpause and see if we get to the same place. All right. And if I do something differently and I get to the same place, just check your math because there's always more than one way to do something. And the way that I go, boom, 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 you might not do the same, which should be fine mostly. That's what your written homework is for, so I can check that. All right, cool. So I want to get rid of this 2. So it's going to be, let's get rid of, actually, let's just move the constant over, equal to 1. Great. And then I'm going to divide everything by 2. So I get x squared minus 2x equal to 1/2. And okay, great. Now I can, so b is -2. B divided by 2 would be -1. So b over 2 squared would be 1. So I'm just going to add 1. All right, great. And then I chose to add 1 so that this would factor into x. What's b minus 2? B over 2. It's -1 squared equal to 3/2. So this would be 4 x minus 1 plus or minus the square root of 3/2. So x would equal 1 plus or minus the square root of 3 halves. And if you wanted to, you could get the radical out of the denominator and write, oh, what would it be? Because it'd be like square root of 3 over square root of 2. And then I would multiply this by root 2 over root 2. So this would be 1 plus or minus square root of 6 over 2, because these are multiplied, so I can move the exponent out. 3 times 2 is 6. I think so. I think this is the same. And that's what x equals. Okay. But I'm perfectly happy with this answer as well. I am not a stickler on that, unless I asked you to rationalize the denominator. So that's why it's good to read instructions. But yeah. Okay. Ooh, another one. So great, this one's already moved the constant over onto the other side, but I still have a leading exponent of 2. So I'm gonna get rid of it. So I have x squared plus 5 divided by 2x equal to 6. Great. Alrighty, so b is 5 divided by 2. I also like to write, the reason I like to write b equals this, b divided by 2 equals this, is because especially when something is divided by 2, I often would just say, oh, b divided by 2 is 5 over 2, which is incorrect. B divided by 2 is 5/4. But that would make b squared over 2, sorry, b over 2 squared, 25 over 16. It's an exponent rule that we had. So x squared plus 5 over 2x plus 25 over 16 equals 6 plus 25 over 16. And I know that that's going to factor to x plus, what's b over 2? It's 5/4 plus, oh God. So, oh, my phone's dead. 6 times 16. So 6 times 10 is 60. 6 times 6 is 36. So 96. 96 over 16 plus 25 over 16 equals 6 and 5 is 11. So 13 and 9, 3 and 9 gives me 127. Is that right? Oh, no one. Oh, no, 121. Where did 7 come from? Oh, okay. This is a nice one. 121 divided by 16. It's nice because both of those are squareds. So I'm going to take the square root. So I get x plus 5/4 equals plus or minus square root of 121 over the square root of 16, which equals plus or minus 11 over 4. So x equals negative 5/4 plus or minus 11/4. And then like, I think it would be fair to assume that I wouldn't, like, I can simplify that answer a lot, right? So I either have that x equals negative 5 divided by 4 plus 11 over 4, which is 11 minus 5 is 6/4, which is 3/2. So 6/4, 3/2. And x equals negative 5 over 4 minus 11/4, which is negative 16 over 4, which is negative 4. So those are our two answers, 3/2 and negative 4ths, which looks a lot easier to understand than negative 5/4 plus or minus 11 over 4. It was just because it was easy to simplify. I wouldn't really take points off. I don't think so, unless I'd be like, simplify your solutions all the way. So just read your instructions on all your problems, okay? So now we've learned by factoring, by completing the square. So what if it just looks crazy? Like I have to divide everything by like 21. and then I had to do 21 squared in the denominator, and it just something that looks like crazy. So if I can't easily factor or complete the square, we're going to finally revert to the quadratic formula. So it even comes with its own jingle, which I'm about to sing. But another reason is it's a good way to check solutions. Other than plugging your solution back into the original problem, if on an exam, I will ask you specifically to complete the square. Solve this quadratic equation by completing the square. Complete the square, and then you're like, is that right? And you plug it in, and you're like, I still don't feel confident. Quadratic formula will give you an answer as well. But if I ask you to complete the square and you only solve the problem by doing it by quadratic formula, I'm going to be like, I'm trying to test you on one thing, you did another thing, I can't give you any points for that. I'm trying to test you if you know how to do that. That's the point of an exam. So if you're like, well, I can do this, I'm like, okay, I test you on that on another problem. Anyways, I digress. So the solution to the quadratic equation, ax squared plus bx plus c equals 0, where, okay, can't equal 0. And that is a good reason why, because you'll see in the answer to this solution is, here's the quadratic formula. So x squared equals negative b plus or minus the square root of b squared minus 4ac da-na-na-na-na all over 2a. Yay! Okay. And that's why a can't be 0 as well, because I would be dividing by 0. If you've never seen the quadratic formula before, you might be thinking, where did this come from? This is so weird. But we're kind of already seeing some things that we've seen before, right? That plus or minus and that square root. You kind of see that that's kind of been showing up when we complete the square. Something plus or minus the square root of something divided by something else. It's kind of been showing up a lot, all right? So where does this come from? We don't know anything about A, B, or C. So factoring, I can't just factor. So my only other tool, I'm trying to derive the quadratic formula, is to complete the square. All right. So I have ax squared plus bx plus c equals 0. Remember, I want my step 1 is to get my leading coefficient. I divide my leading coefficient, and I could boot the constant onto the other side. So I'll have x squared plus b divided by a over, times x, plus c over a equals 0. Just doing one step at a time. X squared plus b over ax equals negative c over a. All right. So step 2 says I need to add whatever twice of this is. So let's call this like bold B equals b over a, bold B over 2 equals b over 2a. And so bold B, I'm just trying not to have two b's, over 2 squared would be b squared over 4a squared. Okay, so I do x squared plus b over a x plus, right, half of that squared. So b squared over 4a squared, and then minus c over a. Oops, I need to move this over. Plus b squared over 4a squared. Okay, cool. So my left-hand side, I know it's going to factor to x plus that guy right here, b over 2a, so half of this, that quantity squared, equal to, and let's combine these to make it one fraction. These, what do I mean by these? These guys. Let's combine these to make it one fraction. So negative c over a plus b squared over 4a squared. My least common denominator would be 4a squared. So that means I need to move 4a over 4a. So this is negative 4ac over, all right, plus b squared over 4a squared. Okay. Oh yeah, negative 4ac. Let's do, I'm writing the negative first. So we write b squared minus 4ac. Oh, there's something coming along. 4a squared. Okay, great. So step 4 is to take the square root and solve. So I'll get x plus b over 2a equal to plus or minus the square root of this big fraction. So b squared minus 4ac over 4a squared. And that would do b plus or minus the square root of b squared minus 4ac divided by 2 over a, since 4a squared is 2a squared. I think that's pretty clear. That a looks weird. I never liked how I write my A's. So please don't ask me if it's a 9. Okay. And then I subtract b over 2a from each side. So I get negative b 2a plus or minus the square root b squared b divided by 2a. So both of those have the same denominator, so I can add them together. I get negative b plus or minus the square root of b squared minus 4ac all over 2a. Great. That is what the tune that my instructor taught to me. So fun. I know some people learn it to like different songs, and I also think that's really fun. But that's how you get there. Ta-da! And that's kind of like writing a proof. So you can even finish it in math. To finish a proof, you can draw this little box. Oh my God, why? All right. And the quadratic is pretty cool. All right. So we'll talk about more about what the quadratic formula can tell us in a little bit. So solve the following using the quadratic formula and state all solutions. So while we're doing these problems, I want you to keep track of how many solutions we get out. We can always, the highest power is at most how many solutions I can get out. So I know already I can get at most 2, but watch how many we get each time and see if you can find the pattern. Okay, so I get x squared plus 8x plus 6. So a would be 1, b would be 8, and c would be 6. So if you want to write the whole quadratic formula out first. And the jingle really helps remember it. So don't knock it until you sing it. All right. So x is going to equal negative b. So negative 8 plus or minus 8 squared minus 4 times 1 times 6 all over 2 times 1. And that's negative 8 plus or minus 64 minus 24. Yeah, divided by 2. Ran out of room. So x equals negative 8 plus or minus the square root of 40 over 2. So I have x equals negative 8 plus or minus, not plus, plus root 40 over 2, and x equals negative 8 minus root 40 over 2. So I have 2 solutions here. That's cool. Alrighty. And you can simplify that a little bit too. I think you can pull out like not a 4, but a 2, whatever. I would be fine with this answer. I didn't mean to go through that. That is our answer. Okay. So next one. A is again 1. B is, careful, don't forget that negative. It's negative 6. And C is 11. So x is going to be negative 6 That's always a tricky one. Negative 6 squared minus 4 times 1 times 11 divided by 2. So that's going to be 6 plus or minus 6 squared is 36 minus 44 over 2. That would give me 6 plus or minus negative 8. But now I have a negative under my radical. That's not allowed. We don't deal with that. So we would just draw an arrow and we would kind of say no real solution. That would be an imaginary solution. So now in this case, I have no real solutions. There's a solutions, but they're not real. So I saw 2 solutions that were real, no real solutions. Okay. And this really should say state all real solutions. I really don't like when people give me imaginary solutions. All right, cool. So sometimes we might need to move things around before we can do the quadratic formula, right? Because quadratic formula is ax squared plus bx plus c equals 0. I need to look like this to find a, b, and c correctly. If not, then something might be negative and gross, okay? So I want to write it as 4x squared minus 12x plus 9 equals 0. Or else you would have been like, oh, the thing in front of the x, well, that's b. And then you would use 12 instead of negative 12, and something could have gone awry. So negative 12 plus or minus square root of 12 squared, or negative 12 squared is 144, minus 4 times 9 over 2 times 4. So now x equals 12 plus or minus the square root of 144 minus 144 over 8. Well, 12, that would be 0. Square root of 0 is 0. Divided by 8. 12 divided by 8 is 3/2. Okay, so what have we seen so far? So that was one real solution. No real solutions. And 2 real solutions. What looked like it was the common factor on if I had on the number of real solutions I had? That plus or minus gives me 2 solutions, but if that square root is 0, I only get 1. If the square root is positive, I get 2 different real solutions. But if it's negative, I get 0 real solutions, no real solutions. So, oh, this is what I'm gonna write down here. B squared minus 4ac is called the discriminant. Discriminant. I need to make sure. Discriminant. I don't know why they make mathematical terms so confusing and hard to spell. I'm not good with letters in that sense, right? So what we saw in problem 1 was that b squared minus 4ac was greater than 0, right? So that would give me that x would equal negative b plus or minus the square root of something positive over 2a. So that would tell me 2 real solutions. Well, then in problem 2, I saw b squared minus 4ac being less than 0. So that tells me that x equals negative b plus or minus square root of something negative over 2a. And we saw that to have 0 real solutions. And then in the last problem that we just did, b squared minus 4ac equaled 0. So x would equal negative b plus or minus the square root of 0 over 2a, which is just negative b over 2a, which is one real solution. So that's how the discriminant can tell us if we have 2, 0, or 1 solution. So you don't even have to fill out the whole thing to know that I had 0 real solutions. You could have just done the discriminant, which is pretty cool, right? Just snore really loud. So let's do our last problem. How many solutions do we think? Oh, that's supposed to be a 2. So how many real solutions? All right, so A equals 2, B equals negative 3, C equals negative 2. So B squared minus 4AC would be 9, which is negative 3 squared minus 4 to negative 2. So 2 times 2 is 4, 4 times 4 is 16, but that's a negative, so it adds, so it's 9 plus 16, 17. So we'll have 2 real solutions. So great. Let me move this down a little bit so we can plug in our quadratic formula. So I have x equals negative, what's my b? 3. So negative 3 plus or minus, I don't even have to do all of that. I just know it's already going to be 17. So square root of 17 over 2 times 2. So 3 plus or minus square root of 17 over 4. Great. So that's another reason checking the discriminant is really helpful, is you don't have to do all of that math inside of this little radical. You can just do it to the side, which is helpful. All right. That's actually all that we have for today. So the discriminant stuff is really fun, I think. It's really interesting. If this was an in-person class, I would have, this like lecture is really, like the word is like, the term is like meaty. There's a lot of substance in it. This stuff is really cool, and it's really fun to like discover on your own, especially completing the square. I think is really, really cool. So I would have loved to have that opportunity, but alas, we're in a panini. So what can we do? All right, this should be the last lecture that you're on for this week. So congrats on finishing your first week of online summer math. Hope it was fun. I will see you guys on Monday. If I can figure out how to stop recording. Oh, okay.